Good morning, students. Today we are going to study the chapter Is Matter Around Us Pure? So first, before studying going to the chapter, we should understand the name of the chapter. That means Is Matter Around Us Pure? So first, understand what is matter and what is pure. So matter means we already know what is the definition of matter. That means anything that occupies space and has mass is matter. So yeah, we can look upon pure. What is the concept of pure? So here it is given. Pure means that there is no mixing in substance. Pure means that there is no mixing in substance. That means if you are taking one type of element, only that particular element should be there. No other mixing of other elements should not be there. So then we call that element as a pure element. So a pure substance is made up of same kind of elements. Okay, same kind of elements, not mixture of elements. Example is given 24 karat gold is an example of pure element or pure gold. Then here is some other things. So basically scientifically when we are speaking, this is the concept or this is the definition of pure. But generally, or we are speaking like pure milk or pure water, pure air, then what is that one? Means is that actually pure or not? Pure milk, when we are speaking about pure milk, just look at the constituents of the milk. Water is there, fat, protein, and so many particles are present in the milk. So actually it is not a pure, because pure means if we are considering about the substance, only that particular type of substance or element should be there. Here there is a mixture of so many elements, and actually when even though we are telling about pure milk, scientifically it is not pure. Okay, so similarly water, pure water. So pure water means actually the only not only the water is there, so many solutes like calcium, magnesium, sodium, chlorine, etc. is present in water. So actually it is not pure water. So air also, and we are considering about air. There are so many gases like nitrogen, oxygen, hydrogen, carbon dioxide, etc. is there. Okay, so this is a concept of pure. Understood? Means no mixing in substance should be there. Then only we call scientifically, means based upon when we are speaking about science, we should understand pure means no mixing in substance. Generally we are speaking like pure water like that and all we are speaking, but in based upon we are looking in an angle of science, the concept of pure should be like this. Okay, now we can move on to study about now this much time we are studying about elements. Now we can go to what is mixture. So mixture, so what is a mixture? Element means only same type of particle should be there. It is a basic elements. So like elements, when we are speaking about elements means metals, non-metals, etc. is coming. So when we are speaking about metals, sodium is an element, potassium is an element. Okay, like that. So mixture means it constitute two or more substance or two or more elements in any proportion. So example, air is a mixture of oxygen, nitrogen, carbon dioxide, etc. So air is a mixture of many gases like oxygen, nitrogen, carbon dioxide, etc. And this mixture is again subdivided, or it is again classified into two. So we can just go to what is first one, that is homogeneous mixture. We can look what is that. These mixtures have no visible boundaries of separation between substances. No spelling mistake is there. Substances. Okay. S one S is extra. So it is a uniform composition. So when we are classifying mixture, it is two: homogeneous mixture and heterogeneous mixture. Homogeneous mixture is the mixture in which there is no visible boundaries present. That means if we are adding solute to solvent, if you are adding solute to a solvent, it will be completely dissolving and there is no visible boundaries. That means we cannot see the solute in solvent. Example is there, sugar in water. What is sugar in water? When we are adding sugar in water, what happens? It will be dissolving and we cannot see the dissolved sugar. This dissolved sugar is the solute, and this water is the solvent, and we are making a mixture. Okay, we are making a solution which is the mixture of sugar and water. Similarly, salt, then lemonade. These are the examples of this homogeneous mixture. Understood? That means there is no visible boundaries or separation. We cannot separate, or we cannot see this solute and solvent. When we are looking, we can see a clear solution. The next one is heterogeneous mixture. So what is a heterogeneous mixture? These mixtures have visible boundaries. While in the homogeneous mixture is not having visible boundaries, but in heterogeneous mixture it is having visible boundaries of separation between substances. It is a uniform composition. It is a non-uniform composition. Okay, that means here look, here it is a uniform composition, means in homogeneous mixture it is a uniform composition. What, everywhere it is a uniform, there is, we cannot separate, or we cannot see any differences in the solution. Everywhere it is a clear solution. But in the case of heterogeneous mixture, it is a non-uniform composition. Why? These mixtures has visibly boundaries of separation between substance. Example, chalk in water or sand in water. When we are dissolving sand in water, what happens, because downside it will be so much sand particles will be spread, and this one will be mixed, because it is suspended. Downside it will be suspended, and here the color will change and it is spread. So it is a non-uniform. Why? Because in downside there is so much sand will be there, and it will be different in different composition, based upon mass, and based upon the solubility also. So many criteria is there. So it is a non-uniform composition. Understood? Because it is not spread everywhere uniformly. It is means not uniformly spread. It is about heterogeneous mixture. Then next one about true solution. So we know what is a solution. Solution is a mixture of solvent and solute. So when we are speaking about this salt solution, salt is solute and water is the solvent. So we are making solution. So what we can look, what is a true solution? Solution is a homogeneous mixture of two or more substances. Solution is a homogeneous mixture. Note this one. It is a homogeneous mixture. Okay, solution is always a homogeneous mixture of two or more substances. Example, sugar solution, salt solution. So solution have two components. One is solute and another one is solvent. So substances which is dissolved is called as solute, and in which is dissolved, it is called as solvent. So the solute is dissolved in solvent. So that substance in which the solute is dissolved is called as solvent. Okay, so solvent plus solute gives solution. It should be fully dissolved, then only we can call it as a true solution. So examples of solutions are given. True solutions. So solution of sugar in water is sugar solution. So we call it as sugar solution. So the solute present is sugar, which is solid. Then the water is the solvent which is used to make sugar solution. The next one is iodine in alcohol, that we call it a tincture of iodine. So the solute is iodine, which is also a solid. Then solvent is alcohol, which is a liquid that we know. Then next example is aerated drinks, soda water. So the soda which we are getting, that means not flavored soda, the plain soda that we are getting in the shop, is nothing but the mixture of water plus carbon dioxide gas. Carbon dioxide gas is the solute here, and this water is the solvent. Then air, when we are generally speaking about air is a mixture of many gases, mainly of nitrogen 78% and oxygen 21%. So oxygen, when we are just consider only two gases, and this oxygen which is least is the solute, and the nitrogen which is the most is the solvent. Understood? So always understand, the substance which is least we are considering as solute, and which is the most or which is more we are considering as solvent. Okay, then what is the properties of solution? So when we are talking about true solution, just understand what is the properties of that true solution. What this true solution shows some particular properties. We can go to that properties. So when we are comparing about this other solution with this true solution, the size of solute particles are smaller. Because why the size of solute particles are smaller? Then only it will be getting fully dissolved here. Then only the sugar or salt will be getting fully dissolved here, and we cannot see that solute particles. The size of the solute particles are smaller. That is the first one. Then second one, solute particles cannot be seen by naked eyes. So once it is getting dissolved, it cannot be seen with the naked eyes. Then particles do not scatter a beam of light. That is a third property. The particles will not be scattering light. Then the path of beam will not be visible. The path of beam of light will not be visible in the true solution. It will not show Tyndall effect. It will not show Tyndall effect. So what is Tyndall effect? We will be learning in this chapter. The next one is particles can't be separated by filtration. So this is the important point. So the particles of the solution, of the true solution, cannot be never separated by filtration, because it is already dissolved. So if you are keeping a filter paper, and it will not be separated by that one. Okay, so it is a stable solution. This is another important one. It is a stable solution. Okay, we can go to the next slide. Now, based upon the concentration of solution, we are dividing. That means this much time we are studying about the solution. So now, based upon concentration of solution, we can classify the solution as different. That means here it is three solutions, three classification of solution: dilute solution, concentrated solution, and saturated solution. Okay, so first one is dilute solution. The dilute solution is the solution that contain less amount of solute. If a solution which is having only the less amount of solute, then we call that solution as dilute solution. So understood, if you are dissolving, if you are taking water, if you are taking 1 glass of solvent and mixing 1 teaspoon of sugar or salt, so it is only a least amount of solute. So if you are dissolving, then that solution is called dilute solution. And what is concentrated solution? The solution that contain high amount of solute is called concentrated solution. So again we are adding 2-3 spoon of salt or sugar extra, then that solution will be changing to concentrated solution. Okay, the solution that contain high amount of solute is called concentrated solution. Then last one, saturated solution. What is saturated solution? When no more solute can be dissolved in solution at given temperature, then it is called saturated solution. That means we are adding solute and solute and solute. Then what happens? Then there a time will come, that means no more solute cannot be dissolved. Now the solution, we call that solution as saturated solution, because it is maximum, it is already dissolved its solutes, and again it cannot dissolve even though small amount of solute by that temperature. We know that if we are increasing temperature, the solubility will be increasing, or the saturation of solution increases when the temperature increases. Means temperature, the solubility is proportional to the temperature. That's why we are putting and dissolving sugar when we are mixing with hot tea. Otherwise we can first initially add sugar in water, then we can mix, but we are not doing so. We are adding to the hot water or the hot tea, only the sugar we are adding. Okay, so saturated solution means it is a maximum, the maximum, already the maximum amount of solute is dissolved, no more solute cannot be dissolved in that solution. Understood? Then next one, how to find concentration of solutions. So in this chapter we are studying about the numericals. So first one, we want to, some problems may come to find mass by mass percentage, to find mass by volume percentage, or volume by volume percentage. So what are the things given in the question? From that we can find. So if mass of the solute and mass of the solution is given, then if you want to find the percentage of mass by mass percentage, then we can use this formula. Then if the mass of solute and volume of solution is given, then we can find mass by volume percentage by this formula, or volume by volume percentage. If volume of solute, this one third one will be usually rarely only using. That means Usually when we are considering about solute, we are taking solid. But here volume of solute means, in the case of liquid, means if we are adding iodine or other solution, as a, we are taking one solution as a solute and another solution as a liquid, then we are using this formula. Okay, so just note these formulas. Mass by volume percentage we can find by mass of solute divided by volume of solution into 100, or mass by mass percentage equal to mass of solute by mass of solution into 100, or volume by volume percentage equal to volume of solute by volume of solution into 100. Then next one, about, we already studied about mixture elements. Now we are going to study about suspension. So suspension is another mixture. Suspension is a heterogeneous mixture in which solute particles do not dissolve but remain suspended. That's why we call it as suspension. So it will not be dissolving the solute particles, but it is just suspended. That means it remains in the water. Example is given: muddy water, chalk powder in water, milk of magnesia, then paints, etc. These are the suspension. So we can look what is the properties of the suspension. Then we are considering about the true solution. We are also studied about the properties of true solution. So here is also some properties. Here the size of the solute particles are big, and we can see with our naked eyes. We can see with just looking, we can see that particles scatter a beam of light. They scatter a beam of light. The path of beam light is visible in suspension. You may or may not see Tyndall effect. Then particles can be separated by filtration. Unstable solution. So this is an unstable solution. Okay, so that one was a stable solution and that cannot be separated by filtration. Here just study this one. Look, the particles are big in size. Then we can see with our eyes. They scatter. Visible. The path of light is the path of light. That means when a light is coming through this, then it is going out to this path is visible. Look, if a light is coming like this, then this path is visible. Okay, so the light path is visible here. So it is an unstable solution. So these are the properties of suspension. Then next one is about, next classification is, first we studied about true solution, then suspension. Now we are going to study of the colloid solution. Actually this colloid solution is an intermediate of this true solution and suspension. Okay, in colloidal solution, solute particles suspended uniformly in solution. Colloidal solution appears as homogeneous, but in actually it is a heterogeneous mixture. So when we are looking about this homogeneous mixture, we seems that it is a homogeneous mixture and it is not a heterogeneous mixture, but actually it is a heterogeneous mixture. So example, what is meant by colloidal solution? So what is meant by colloids? It's like milk or blood. Okay, so the properties of colloid solution is given. So the first one is, size of solute particles are bigger than solution but smaller than suspension. So I told you it's an intermediate between the solution and suspension. So the size of the solute particles are an intermediate between the solution and suspension. Okay, so it is not that much big and not that much small also. Can't seen by naked eyes. We cannot see that particles with our naked eyes. The particles scatter a beam of light easily. They scatter a beam of light easily. Path of beam light visible in colloidal. We can also see the path of light. Then always show Tyndall effect. In suspension it is not always. It may or may not see Tyndall effect, but here it always show Tyndall effect. Particles can't separated by filtration. Suspension, the particles can be separated by filtration, but here we cannot be separated. We know milk and all, the particle, we know many particles are present even though we cannot separate by filtration. It is a stable solution. It is uniformly distributed, so it is a stable solution. Then we can look what is Tyndall effect. Here we are two times we are studying Tyndall effect. Now we can look what is Tyndall effect. The phenomena of scattering of beam of light due to the presence of colloid particles. If there is a colloid particles, with the help of those particles the light gets separated or light gets scattered. That property is called as Tyndall effect. Hmm? So due to this effect only we can see the path of light. So three example is given. So first one is in a dark room. In a dark room the light ray is coming and it gets scattered with the particles or dust particles. So many dust particles will be there. Okay, so the light is separated. So the light is scattered. The light is scattered with those dust particles. Then next one, in a dense forest, when the light rays are coming, there will be fog in the morning time and all. The light gets scattered with the help of fog. So that is also the we can visible the path of light. That is Tyndall effect. Due to Tyndall effect, that is the particles is the fog there. The colloidal particles which is present is the fog in the forest and it is the dust in the dark room. And the third case, look, here is two solutions. Here is it is true solution and here it is colloidal solution. So in true solution, this one is a laser. Okay, this is a laser, right? Laser light. So in true solution we cannot see the path. Here the path is missing. Here the path of light is missing and we can only see the starting and ending points. But in the colloid solution, this is a second one is colloid solution, we can see the path. This path we can see. Okay, so this is the difference of that true solution and colloid solutions. Understood? Then next we are going to study about the separating the components of a mixture. So this much time we are studying about the how the solution, what is the properties of the solution, or what is Tyndall effect. Now we are going to study about the separation of that mixtures. We are studying this much about the mixtures. Now we are going to study the separation. How many methods of separation is there? How we are going to separate the particles or how we are going to separate the mixture. Okay. So first one is evaporation. So in this process we can separate two components of mixture in which one can evaporate. So if we are getting a mixture of two substances in which one is having the property of evaporation, or means one element can be evaporated, then we can separate or we can use this evaporation for separating those elements. So example is given. If you are getting ink and we want to separate dye and water, or if you want to take out this dye, we can use or we can go for this evaporation method. So ink is a mixture of water and dye, we know. So if we are keeping the ink here and we are boiling water, then what happens, this water will be evaporating after some time and only the ink will be remaining, since ink is the mixture of water and dye. So ink means water plus dye. So every water will get evaporated and finally the dye will be remaining and we can separate this dye. Okay. Next, separating is by centrifugation. So centrifugation is a rotating separation for this things based upon the weight. They will be based upon the density or the mass. We can separate these items. So how this is with the help of gravity. That means here is one rod will be there. Here one rod will be there and this will be rotating. And what happens, it will be rotating in such a high speed, that means 1000 rpm or 10,000 5000 rpm. Rpm means rotation per minute. In minute they will be rotating like 5000 6000 7000. And it will be like for 10 minutes 15 minutes and all, it will be rotating. Then what happens is the gravity will be high. So the gravity will be high and what happens will be is if the mass is more, it will be settling down. If the mass is more, the substance will be settling down, and mass is less, it will be above. So we can separate by using according to the mass or densities. So in this process mixture is rotated very fast, then the denser particles are settled out and lighter particles stay at the top. So applications of this centrifugation is used in diagnostic laboratories for blood and urine tests, and it is used to separate butter from milk. So butter is light in weight and it will be coming above. Then used in washing machine to squeeze out water from wet clothes. So these are the uh, applications of centrifugations. Okay. The next one is separating funnel. So separating funnel is another mechanism or instrument for you separating things. So how this one is? So here is one opening. We can look how this working of this separating funnel. Here is one opening. So we are putting mixture to this and we are closing. Then this separating funnel, now this is working by the principle of, by this process two immiscible liquids separate out in layers depending on the densities. That means only we can separate two immiscible liquids, which will not be mixing with each other. So if you are putting, then what happens? Then what, here one example is there, separation of water and oil, they will never mix together. So water will be downside and oil will be above. Now what happens, here is one opening. When we are opening this one, all the water will go and we are collected. Then when once the oil is reached here, we will stop. Now the oil is inside this one and water is we got in another beaker. Okay, this is how we are using for this separation. So this will be used for separating of oil and water, then extraction of iron from its ore. So similarly, the iron is heated. The iron or iron ore, it's a mixture of soil and this iron or other metals. Then once it is heated, it will be liquid. Once it is liquid, this iron is having more density than all other elements, all other its ore elements. So similarly, the instead of water, the iron will be downside and we are separating iron from its ore. Like that only it is using, this separating funnel is using for the separations. Then next one is about sublimation. So sublimation, we are using sublimation only for some materials. Like in this process we can separate sublimable component from a non-sublimable component. That means one component should be sublimable and another should not be sublimable. What is sublimation? Means the element should have the capacity to directly go from solid, or if you are heating an element, it should directly from solid it is becoming vapor. That process or that elements, we call it as sublimation. So that process is called sublimation. Okay, so the application of sublimation, so application of sublimation, that means many mixtures that contain camphor, naphthalene, androgen, ammonium chloride, which these are the elements which shows this phenomenon. So these all we can separate it by using this sublimation. So if we are keeping the mixture, then we are closing with a cotton, here, then we are heating. Then what happens, the camphor get evaporated and here it's get cooled down, and it will be settled, means it will be solid. So it's how this is separated. So the camphor is separated in this funnel. Okay, then we can look next one. The next separation is by chromatography. So what is chromatography? So in this process, different components of a mixture are separated due to their differential movement in stationary solvent. So actually this I will tell how is this one. It means this is a chromatographic paper. Chromatography, actually there is many type of chromatography. First you understand there is one paper chromatography, that is one chromatographic paper is there. We are putting ink here. We are putting ink. We are putting ink here, and this is the solution in which we want to separate. And we are dipping partially into this solution and keeping this paper stationary. Then what happens, this solution is partially touching to this water. So what happens is that the water will be coming upside, the ink is present here. So the sorry, where is that one? Yeah, So you know what, this water will be rising up above. The water will be rising up, and the water is having many particles. So the particles which is having different properties for the movement, there will be differential movement in the stationary solvent. Hmm? So the particles movement will be different, so that the ink will be, the water will be coming out and taking the ink, and it will be spreading. That means the ink black color is having different colors. So after some time what happens is, somewhere it will be yellow, then somewhere it will be red. So means it will be some of the particles will be lying in different portions. So according to the movement it will happening, so we can understand the particles is having this much velocity or this much speed or this much mass. It depends upon many criteria like mass, charge, velocity, etc. So this is the movement taking place in the chromatography paper. You can imagine if a lighter element is there and heavier element is there, so the lighter element will be moving fast as compared to that heavier element, and it will be in front, and the heavier element will be in the back. Okay, so this is applications of chromatography, used to separate colors of dye, used to separate drugs from blood. So these are the applications for chromatography. The next one is distillation. And what is distillation? So in this process of mixture of mixture of two or more miscible liquids can be separated that have different boiling point. If you are having two miscible liquids as a mixture and which is having two different boiling points, when we can use this method of separation, that is distillation. So in distillation what happens when we are heating, then first, that means two solutions are present in this bowl. So after heating some time, then what happens is, the liquid which is having least boiling point, then it will be getting evaporated and coming through this distill adapter, and it will be moving to this tube. So here it is condenser, that means here the temperature will be low and this gas will be converted to liquid, and here it is separated. That means here is an example, separation of acetone and water. So this is a mixture of acetone and water. Then once it is heated, what happens, acetone is having low melting boiling point, so as soon as getting small amount of temperature, it will be evaporating, then it will be going to this distill adapter and coming through this condenser tube. So once it is reaching condenser tube, the temperature is low and it will be getting as a liquid. It will be converted to gas. From gas it is converted to liquid and it is collected in another conical flask. So this is how we are separating through distillation. The next one is fractional distillation. So in that distillation only two liquids we can use, and that also should be having a different boiling point. This different boiling point is not that much near, it should be different. It means water and acetone is having high difference in boiling points, but fractional distillation we can use which is having nearby boiling points also. Okay, so we can look how is this one. It is same as distillation, but one additional thing is there is that it is having fractionating column in which some of the structure, that means it is having some uh, internal structures. So this is made such a way that once the, look, imagine here it is here application of fractional distillation in the separation of oxygen, liquid, nitrogen, argon and gas, used to separate crude oil components like petrol, kerosene, diesel. So many elements will be there. So if one element and next element will be like somewhat near in temperature, so what happens, when we are keeping, the first element is 50 degree and second one is 55. So once we are heating, then first the 50 degree boiling point element will be rising, then after some time 55 also will be rising. But once this 55 is reaching here, this is made in a such a way that it will be, from here itself it will be converting to liquid and it is suddenly coming downside. Only that temperature which is having less boiling point is allowed to go through this condenser tube and it is collected here. Then after that collecting fully that one, then next the temperature is increased and next one is again collected through this, then third one is collected, like that each is separated in the conical flask. So these are the applications of fractional distillation. The next one is crystallization. In this process, impure mixture first dissolve in a suitable solvent, then crystallization of one component. So example, salt. Salt, we are first dissolving impurities with the salt solution and preparing, and it is crystallized. The salt is separately crystallized, then it is taken. So it is used in purification of salt from sea, and it is used in separating alum or copper sulfate. The next one is about the physical change and chemical change. So there is change. So either it will be physical change or chemical change. So we can look how we are classifying, what is the difference between physical change and chemical change. This change is temporary and reversible. The physical change is a temporary change and it is reversible. That is, example is given, melting ice or dissolving of sugar or salt. So that is physical change, and there is no new formation of new products. There is no formation of new products. No new products are formed in this physical change. There is no energy change in these products. There is no energy change also. So this is the physical change. Then what is chemical change? This is the example, means this is just opposite of that physical change. These are permanent and irreversible. Irreversible and permanent. There is always a formation of new products. Energy is either absorbed or evolved. Okay, the energy will not be means initially and finally it will not be same. It will be either absorbed or it will be released. It will be increasing or it will be decreasing. The example, so example is wood burning. So burning of wood means it is irreversible change. Okay, so next one is about, we are classifying into elements and components. So the pure substance we are classifying into elements and components. So based upon, first we are classifying into elements. We are classifying into metal, non-metals or metalloids. So elements constitute pure substance in which all atoms are same. So you know what is pure substance? I mean, so only one type of element should be that. Okay, so what we can look, what is metal, what is non-metal, and what is metalloids. So here are the properties of metals, properties of non-metals, and properties of metalloids given. So first one is about metals. Metals is having the properties. I mean, metals are lustrous. They are shiny in appearance. Metals always conduct heat and electricity. They can be drawn into thin wires. That property is called as ductility, or metals are ductile. Then they are malleable. That means they can be made into thin sheets. They produce sound, so it is called as sonorous. Example is given, gold and iron. Then next one is about non-metals. Non-metals are non-lustrous. They are not shiny in appearance. They do not conduct heat and electricity. Non-ductile. They can't drawn into wires. They are not malleable. They cannot be made into thin sheets. They will not produce sound. Example is coal and oxygen. Metals have then next one is metalloids. Metalloids have intermediate properties between metals and non-metals. That means some of the properties of metals and some of the properties of non-metals. It is an intermediate property. So this is about metalloids. Example, silicon, boron, germanium. These are the examples of metalloids. Then next one is about compound. So first we studied about this one, elements, metals, non-metals, and metalloids. Now we are going to about compound. So two or more elements combine chemically in a definite ratio to form a new substance is called as compound. So a compound means there will be more than one element. So here is one example is there, means hydrogen and oxygen react to form water. So here actually what is happened, hydrogen and oxygen are two gases. It is formed or reacted to form water, which is a liquid. Here the substance cannot be separated by physical method. Here we cannot separate this hydrogen and oxygen with physical methods. This will be showing entirely different properties than the reactants. Reactant side it is hydrogen, oxygen, or product side is water. Both the properties is different, means even the Physical state is also different, means oxygen and hydrogen was initially gases, then they converted to liquids. So this is about the compound. So this is about the whole chapter. So is matter around us pure? So in this chapter we are actually studying about the pure substance, then what is a mixture, then what are the different types of mixture, then what is a true solution, examples of true solutions, then what is the properties of true solution, what is Tyndall effect, why it is showing Tyndall effect. You know why it is showing Tyndall effect? Because the particles, if the particle size is able to hit the light which is coming, then it is getting scattered. If the particle size is very small, it will not be scattering. If the particle size is large, then it will be scattering. Then about the concentration of solution, then numerical formulas we studied, then about suspension and properties of suspension, then about colloid solution, examples of colloid solution, milk and blood, then what is Tyndall effect. The colloid solution will be always showing Tyndall effect, the suspension showing will be sometimes showing Tyndall effect, but the true solution will never show Tyndall effect. Then what is evaporation and where we are using this evaporation to separate. What is centrifugation, where we are using this centrifugation to separate. Then what is separating funnel, what is the use of separating funnel, how it is working. Then how the sublimation, or what we why where we are using sublimation to separate. Then where we are using chromatography, what is distillation, what is fractional distillation. Then how we are using crystallization, or where we are using crystallization to separate. Then what is physical and chemical changes. Then what is mean by elements or classification of elements we study. Then what is mean by compounds, or this is the things we are studied. So if you are having any doubts, you can ask me in the comment section or message me personally. Thank you.